Hi Zach! Welcome back to my dorm room. Today we're going to be doing continuity and discontinuity. Continuity is usually defined in the simplest terms as the property of a graph to be drawn without picking up one's pen or pencil. Most of the functions you've been working with throughout your time in algebra and pre-calculus have been continuous functions such as x cubed. The more mathematical way to describe continuity is when the limit of f of x as x approaches c is f of c. What that means is that the limit is equal to the value of the function. So there can't be a hole in the graph or any other place where the graph is not defined. A discontinuity, on the other hand, is the total opposite of a continuity. And there's three specific types of discontinuity that we typically talk about in calculus. The first is holes, which is a specific point where something is not defined. Jumps, where the y value is totally different from one point to the next. And vertical asymptotes, where at a specific x value, the function goes either to positive infinity or negative infinity, or both. One more thing I should note is that for holes, the limit exists. Meanwhile, for jumps and vertical asymptotes, the limit does not exist. And how does this fit into calculus? Well, imagine trying to find the slope of a point that's not defined. There's no way to do that. And so you can't take a derivative of a graph that is not continuous on the interval. First, I'm going to do an example with you. In the example, I want you to find the intervals where the function is continuous and identify the types of discontinuities in the graph. Our example is x minus 5 over x to the fourth minus x cubed minus 16x squared minus 20x. The first thing we're going to do is factor both the top and the bottom. Obviously, the top can't be factored because it's already fully factored, but the bottom can be factored into x minus 5 times x plus 2 squared times x. When we have a factor in both the numerator and the denominator and we can cancel it out, that is where a hole occurs. For the factors in our denominator, x plus 2 squared and x, that is where vertical asymptotes will occur. For x plus 2 squared, the function will go up to positive infinity at the point x equals negative 2. And for the factor x, the function will go up to positive infinity on the right side and down to negative infinity on the left side as the function gets closer to 0. So the function is defined from negative infinity to negative 2, then from negative 2 to 0, then from 0 to 5, and then from 5 to infinity. At those exact points, negative 2, 0, and 5, that is where the discontinuities occur. At negative 2, there is a vertical asymptote that goes up to infinity. At 0, there is an undefined vertical asymptote. And at 5, there is a hole. Find the intervals of continuity and where the function is discontinuous and what type of discontinuities are at those places where the function is discontinuous for x cubed plus 15x squared plus 62x plus 72 over x squared minus 5x minus 36, and for the piecewise function where the function is x for x less than negative 2, x squared for x greater than negative 2 and less than 1, and x cubed for x greater than 1. Finally, find a value of a so that the function is continuous for the piecewise function x squared minus 4 for x is less than negative 2, and x cubed plus 8x squared minus ax minus 32 for x is greater than or equal to negative 2. This is the challenge question. It's totally okay if you don't get it right the first try. Until next time, bye!